Number 4 on the Illuminate study guide. So we have a few different functions graphed on the same coordinate plane. And you're being asked which of the functions, if any, eventually exceed the f of x function as x approaches infinity. So take a look at what all of these different graphs are. So we have f of x, h of x, and g of x. What type of function is the f of x function? Hold on, I'm going to switch to the screen for a second, but okay, but the question I'm asking you is what type of function is f of x if it looks like 2 to the x power? So it's not quadratic, but try. For it to be quadratic, what does it need to have in it? An x squared. There can be other things in it, like, I don't know, x squared plus 2x plus 1 or something to that effect. But it can't be higher than an x squared. And it needs to have an x squared for it to be quadratic. So what is it if it looks like this, 2 to the x power? What are some other types that we've talked about? Did you say vertex? So that is still a quadratic when it's in vertex form. Think like whole year long. We focus on 3 types of functions all year. Okay. So if it's 2 to the x power, that's an exponential function where the variable itself is the exponent, like a times e to the x. Now, what type of function is g of x? Slope-intercept form, so it's linear, because it is in slope-intercept form, y equals mx plus b. And what type of function is h of x? Based on how it looks and the equation? We've now talked about all the ones from this year, so it's going to be one of these 3. Which one does h of x most resemble? Linear. So I really need your eyes up here. Like, I get that you might not necessarily need help with this question, but some of you that are like not making eye contact, I'm just like, I'm gonna see you next year. I'm gonna see you in summer school. You need to pay attention right now. And then maybe that one. All right, so anyway, yeah, we have an exponential, a linear, and a linear. One thing you need to know by the time you leave 9th grade is which of these functions always exceed the others. So would that be an exponential, a quadratic, or a linear that will always eventually exceed the others? Nope. Exponential. Remember, if something grows exponentially, it's growing at a really fast rate. All right, because it's multiplying each time. Whereas linear is adding each time, and then quadratic's just like a bit different. It goes up and then down, or vice versa. So exponential functions will always eventually exceed any linear or quadratic. I know there's not a quadratic example on here, but there will probably be one tomorrow. So you need to know exponential functions will always eventually exceed the other kinds we've talked about. So when it says which of these functions, if any, will eventually exceed f of x, the exponential, what would you say? And it might be shuffled on your screen. So my A says g of x. Okay, so C on my screen would be right. None of the linear functions will exceed an exponential. So for this one, the answer is neither. Don't just memorize that answer because it will probably be different on your test. It might be asking which ones will exceed the quadratic, which ones will exceed the linear. But no matter what, you need to figure out which one is exponential, and that one will always exceed the others. Questions on that? Okay, questions on others? Steven? Number 10 on the Illuminate. In case you guys are following along with those answers. All So for this quadratic, we're writing an equation for the line of symmetry. I'm really glad we asked about this. Because it maybe came up once when we were taking notes and we really didn't have an opportunity to practice it. But you are being asked that on your test. So think about what it means for something to be symmetric. What does it mean for something to be symmetric? Okay, so same on both sides, meaning that if I draw a line down the middle, and this is what our quadratics look like, so if I draw a line down the middle, it should be a mirror image on both sides. So that's what we're asking, is the equation for a line that goes right down the middle of our quadratics. What also goes right down the middle of our quadratics? Did you say y? I'm not hearing what I'm looking for. What also is right in the middle of our quadratic function? The vertex. So if you can identify the vertex and whether that is by graphing, by algebraic problem solving, then one of those values is gonna be a part of your line of symmetry. All right, here's the actual formula for line of symmetry. There is a formula. So if you were making flashcards, maybe make a flashcard for the line of symmetry formula. It's x equals negative b over 2a. So when you get to this problem tomorrow on your test, you need to have x equals in your answer. Otherwise, it is technically wrong because we're looking for a line. And lines that are x equals a number will always be a vertical line. So that's what we're looking for. The b and the a come from your ax squared plus bx plus c. I know we don't have a c in the line of symmetry formula, but later on you will use the c. But for line of symmetry, we don't need it. So if I plug into this formula, b is always what's in front of the x term. So what's going to be my b value? 8. So I'm plugging in an 8 for the b. Over 2 times a is always in front of the x squared. So even if they write it out of order like they did, what number is in front of the x squared? A 2 is in front of the x squared. So it's going to be 2 for the a. And then simplify, this becomes a negative 8. This down here, 2 times 2 is 4. When I simplify this with the negative 8 divided by 4. So this is going to be my line of symmetry. X equals negative 2. So you can memorize the formula. I memorize the formula. I think it's like my favorite way of solving. But because we didn't do a whole lot of practice with it, and maybe if you forget tomorrow, just remember, and it's not going to be multiple choice tomorrow either, just so you know, like, I try to make the study guide exactly how it is on the test. But just remember what it means for something to be symmetric, and that the line of symmetry should be going right down the middle. So if I copy my equation, and then I write down in a different cell what I think my answer is, x equals negative 2, it should be giving me a line right down the middle. So you can check your answers, see if it's right. Or you can completely forget how to solve, look at your vertex. It's going to be the x of your vertex. So x equals has to be in there so that it makes a line, and then whatever the x of your vertex is. Okay, questions on that? Questions on others? Brady? 7 on this study guide. Okay. So number 7. We have, what are the zeros of the function below? What's another word for zeros? X-intercept. So you have a few ways of solving this. I mean, in the next unit, because that's also quadratic functions, you'll learn a ton of ways. But I think the extent of your knowledge in this unit, because it's in standard form, is just gonna be to graph it and see where it touches the x-axis. So 6x squared plus 12x minus 48. I'm pretty sure type it in right, or just make sure, okay. So that's what I would do. Zeros are x-intercepts, I would type it into Desmos. I would see where it touches my x-axis. And the way that it will want your answers though, and I again made it just like the test, of course, I'll probably have to go back and give points to everyone who types it in coordinate form. But the way it wants it on the test will be you typing in -4 and +2 it was, I think. But that's how it was wanted. It doesn't want it in coordinate form when you put it in on the test because it says x equals. But I will give points if you accidentally put it in coordinate form. Okay, so questions on that one? Questions on any others? From any study guide, optional, or constructed response. Yes. Yes. 9 on this one. All right. Okay, so select all statements that could describe the transformation of the following quadratic. And when we talk about like describe the transformation, unless it gives you another equation, then we're always comparing it to our parent function. So you have a few options again. You could memorize all the transformations that we went over in the lesson. Or you could graph it, both the parent function, but of course you'd have to remember that x squared is the parent function. And then the other one, so -2 x plus 3 and parentheses squared. And then I want to say it was +4. Okay. So I typed in my parent graph, my original, and I typed in my transformed one. Think of all the changes that happened to go from our purple to our black. And I think the vertex might be a good place to compare. So from the purple to the black, did I go up, down, left, right? I went up how many? I went up 4. Did I go left or right at all? Left how many? And then how can I make it inverted? What makes it inverted? This -2 that's here. So it's inverted. So what do I call that when it's inverted? Good, that's a reflection over the x-axis. And then also the fact that this is a -2, like it's not a -1 before the number in front of the x squared was a 1. So this part you might have to remember, it might not be as easy to see. But when it's a -2, does it get any wider or more narrow? So and we call that in math, what? A compression is when it gets wider. So we call it a stretch, a vertical stretch. So this is my original, that's wider. This one's my transformed, which is more narrow. Think like when you have an image on your computer and you like change the dimensions. If I just stretch it upwards, whatever's in that picture is going to get skinnier. Okay, so that's the difference between. That's the difference between stretch and compression. So anyway, going back to my question. We need to put that it goes up 4, left 3, which you can see like where that is in the equation. We talked about when that happens, what it does to the equation. So it definitely makes sense. You could have done that part without graphing if you memorize it, but you can also just type it in. And then we need to put the reflection and that it is stretched. All four of those things would need to be there to get the full points on this one on your study guide. And of course, it could be in a different order, so make sure you just pay attention to how it is on your screen. All right, questions on this one? Questions on others? Brady? Number 11. Okay, so which of the following statements is true concerning this quadratic function? And we're talking about the zeros. So zeros are what again? X-intercepts. So you can graph it. We haven't really talked about how to find zeros from standard form. So you'll have to graph it. Next unit, we'll teach you how to do that algebraically. So you'll just have to graph it if it's in standard form. So x squared minus 8x minus 20. And let me just make sure I typed it in right. That's what you should always go back and double check too when you take your test. But it looks like my zeros are -2 and +10. Now with this question, that narrows me down to two options. -2 and +10. It narrows me down to these two. They both say that the correct zeros. What's different is that it gives us two different factor forms, which we learned in this unit how to easily tell the zeros from the factor form. Okay. So which one's going to be the right answer? The one that says x minus 10, x plus 2, or x plus 10, x minus 2. And that is correct, because we notice one, like kind of a pattern, the zeros tend to be opposite signs when they're in the equation. But the question, because I know the test, might be more procedural, like why is it those zeros? And this is why. X-intercepts by definition are when the y equals 0. By definition, at the x-axis, all the y's are 0. So what you would really actually do in solving this, since there's two ways we could get to 0, that's why there's two x-intercepts. You have to set each factor equal to 0 and then solve for x. Okay, that's whenever you multiply and one of the numbers is 0, that's what gets you 0 for your final answer. There's two ways to do that. One where x is 10, that's why 10 was one of our zeros. And one where x is -2. So keep that in mind. The question might be more procedural, but also you need to be able to identify the right zeros anyway. Questions on this one? All right, questions on any of this? Number 5 on this one. All right, so we have this function below models expected net worth in millions of dollars of a certain company after X years. Complete the blanks to make the statement true. So we have the equivalent form shown here, reveals that the company's expected net worth is 0 after blank years and after blank years. So few things that can help you here. The two things being compared, net worth and years. What would have to go on my x-axis? Net worth or years? Years. Time is almost always on the x-axis. So that means my y value is net worth, or my y-axis is for net worth. if it's asking me when my net worth is gonna be 0, where is it 0? What part of the graph is my net worth 0? Is it 0 up here for my net worth? Where would it be 0? At the x-axis. So when you graph it, because I mean, you don't need to graph it, but if you graphed it, maybe that'll be helpful to you. I know that since the x squared is negative, that it looks something like this.
I don't really care for you with like
All right, anyway, it'll look something like this. Pretend that's a perfect U shape. So you need to find where it touches on the x-axis. It'll touch at 2 different places. It has 2 x-intercepts, 2 zeros. You can graph it and get that answer from there. Or you can look at this form that they gave you. What form did they give you? They gave me factor form, and we learned that in factor form, it's really easy to identify the zeros. What are my zeros gonna be? 4 and 12. But again, you could graph it and see where it touches. It'll tell you it touches at 4 and 12. You just kind of have to use your common sense. If my Y values are for net worth, where is it 0? There's 2 places that it's 0. At the X values of 4 and 12. Okay, questions on that part? Now look at the next form that they're giving you. What do you recognize this form as? I don't want to scroll because I don't want to ruin my writing. But this form down here, what do we call it? Nope, standard form is what they gave us originally. The only thing you can really tell from standard form is your y-intercept. But from vertex form, this is what this is down here. What can you see really easily from vertex form? The vertex is in the name. So even without graphing, I can tell you my vertex for this one is going to be what? Good. So even without graphing, I can tell from vertex form that that's what it's going to be. But of course, you could always graph it if that makes more sense to you. Because what it's asking about is what the company's maximum expected net worth is and when it occurs. So if knowing that X is for years and Y is for net worth, what needs to go in this first box? 0.32, and then that occurs at what time? Okay, good. So honestly, graphing can find you maybe like half of your answers tomorrow. I still don't necessarily recommend it as a starting place, but you know, check your answers. You'll probably have time tomorrow. Questions on that? Okay, questions on any others? Yes. Question 3 on this study guide? Yeah. Okay. So a projectile fired into the air, this equation can be used to determine the height of the projectile after t seconds. We want the domain and range of the function. So domain refers to all the what in a function? X's, and range refers to all the what? So keep that in mind. You can graph that and see how it looks. But what would have to go on the x-axis? Height or time? Time in seconds. Which means my y-axis is representing height. And it didn't give me like a dimension for height, like feet or meters, but just know something along those lines is what your height is going to be. And the reason why that's important is because you have to kind of ask yourself, for my domain, what's a reasonable amount of time? So can the time be negative? So no negative numbers. Can it be decimals for the time? So also it has like different intervals, so we might actually have to graph it and see where it starts and ends. So 48t minus 16t squared. I'm gonna change the t's to x's, so I don't have to type in the whole thing, just this part. Okay, but 48x minus 16x squared. Here's where my domain starts and ends. Because like you said, it can't be negative. But it can be everything between 0 and 3. So that narrows me down to 2 options. We're gonna cross out the ones that have the wrong intervals for the domain. And even these 2 options, one of them says all whole numbers from 0 to 3, and the other one says all real numbers from 0 to 3. If we're allowed to have decimals for the seconds, then which one does it have to be? All real numbers from 0 to 3. So that excludes the negatives when we say from 0 to 3, but it allows the decimals. So already I know my answer just based off of the domain. But the range does make sense because if you look at your graph, you can't have a negative height, can you? So the range will start at 0 and end at the maximum, which that maximum height is 36. So this one also says it consists of all real numbers from 0 to 36, which you can have decimals of a foot or a meter. So that makes sense. All right, we might have time for one more, depending on how long it is. Number 6. And then keep in mind, like I'm recording all my classes today, even the Kahoots. I'll have the Kahoot link posted. The Kahoot is more to help with the constructor response anyway. You said 6, right? But everyone should have hopefully a turned-in study guide at 80% or higher. So what is the completely factored form of the expression below? We have not yet taught you how to go from standard to factored. We showed you how to go from factored to standard. So what you'll have to do is multiply all of these out and see which one matches your original. Okay, so you could FOIL, you could double distribute. What do you guys like better? Okay, so if we FOIL these, multiply the first terms with x times x. Then the outer x times 9. And it's positive, put plus 9x. Inner terms, 4 times x. And my last terms, 4 times x is, or I messed that up. 4 times 9 is, and it's positive. I could combine like terms, but I'm already seeing, is it going to give me this as an answer? Not this one, because it has a positive 36. So even before I combine like terms, I know it's not going to be that one. And then you just kind of multiply them all out until you get your right answer. So if I do this one, first terms, x squared, outer terms, negative 9x, inner terms, positive 4x, last terms, negative 36, it's looking pretty close. When I combine like terms, what's negative 9x plus 4x? And now I found the one that matches. So for me, it's this option, but you gotta pay attention to your own thing. If you're just getting the answer from me. How to do it is to actually multiply them out and see which one matches your standard form. Okay, good. Make sure that if you don't ask, I guess you just never know. So email me if you need to, watch the other videos. The Kahoot link will be posted.